Welcome back to my tutorial series on how to make a game using Flutter and Flame. In this episode, we're going to set up player movement, as well as adding keyboard controls for desktop and touch controls for mobile. So let's get started. So to get started, we want to go to our player.dart file, and we're going to add a lot of code in here so that our player can move. Just like how we have a player state, we want to make another enum called player direction. This will allow us to keep track of our player's direction, which will change later on to make our player be able to move left, right, or be idle. So we can do player direction, and then for here we can list off our different directions. We have left, we have right, and then we have none. You can call these whatever you want as long as it makes sense for you, but left, right, and no direction, aka none, makes sense to me, so that's what we'll use, but these don't have to be exactly this name. So now that we've set up our player direction enum, what we want to do is we want to get a reference to that. So right here, after we set all of our information for our sprite animations, we can come down and we can do player direction lowercase p for player direction. We're going to make a local variable of it, and then by default we're going to set our player direction dot none. And this is why enums are very great, because we don't have to type in with strings. We can just grab the information and compare to it or set it, and it knows what it's trying to do. Plus, this is much more readable. Our player direction is player direction dot none. Now, because we want to be able to move our player, we're also going to need to add a few other things. The first thing we're going to want is we want a double, which means that it could have a decimal point. We want a number that we'll use for our move speed. So we'll do double move speed equals, and by default, we'll just set it to 100. Now, in order to make our player move, there's a few different ways that we can do this. We can either just change its position and add on our move speed, but because we want it to be more dynamic, especially if we're going to change stuff later, it's actually better to just make a variable called velocity, change the velocity, and then set that to our player's position. That way we can control the X and the Y exactly how we want. So to do that, we'll do a vector2, and then this vector2 will just be called velocity, and then by default, we'll set it to vector2.0. Vector2.0 just means 0 on the X and 0 on the Y. If it's both going to be 0, just like how we use all, if it's all going to be the same number, we can just do 0 if it's going to be 0. Cool. So now we have the variables that we need right now. We'll come back. We do have to add one more, but I'll show you why in a moment. So we have our move speed, our velocity, and now we have our player direction. So what we can do here is we can come down and we need to add something that we don't have yet, and that's we need to add our update function. So our update function, just like our onload function, is a built-in function that we can override. The onload only happens once when you load the player in this scenario, but the update function happens every frame. So what we can do just to keep it clean, we'll do it right below our onload. We'll keep all of our main functions that we're using at the top, and then any of our special methods that we've created or other information that we've created will be at the bottom. So we can just do onload. Nope, we're doing update, so we'll just do update, and then we can actually see void update. It will override for us. Now with the update function, it has this right here, which is DT. If you know anything about game development, you'll see delta time all over the place. And the reason why is because the update function will update as many possible frames. So if you're on a computer that gets 10 frames, it's updating 10 times a second. If you have a computer that's really good, or if your game's really small like ours is, it's probably updating thousands of times per second, hundreds or thousands. So the delta time allows us to just check how many times have we've updated in a second, and then it'll divide it by the correct amount. So that way you always get the same amount of frames that have happened that we'll be able to update for. Whether we have 10 FPS or 1000 FPS, everything will still run at the exact same amount of time because it gets offset because if it's lower or higher. Hopefully that makes sense. You'll see it in action. I'll actually show you an example of why we use delta time, but I want to just explain that because that might be new to you if you don't do game development. Now, to keep our code clean, we always like keeping our code clean, so we're going to create another method for us. We can do underscore update player movement. Again, you can call this whatever you want, but we're going to do underscore update player movement. The underscore means that it's private, and then we need to pass in the delta time because we're going to use it. Again, we want to use delta time, so we can actually pass this in the variable in our method. as a variable or a parameter. And now we can hit control period, and then this will give us the ability to create a method, save us some time, and we'll create the method. Now the method will get thrown down here, which is completely fine. You can always move those around if you need to. So in our update player movement, what we want to do is we want to add the ability for our player to move. That makes sense, right? So we can do this by first we want to create direction in our X. Our direction in our X is going to be either positive or negative. If we're going to the left, it's going to be negative, and if we're going to the right, it's going to be positive. So we can create a double here, and then this double, we can just call it whatever you want, direction X, dir X, if that makes sense. Dir X, we can call it that, and then we'll just do 0.0. And this is essentially the direction X that we're going to be using. Now, we already have our player direction, right? We made an enum at the top of our player direction, and we're actually going to use that here to see which way our player is going. So to do this, we can just do a switch statement. And then this is why we made a local variable of our player direction. And we can call in the expression is our player direction. So a switch statement is essentially saying we're going to see what this is, and then based on what this is, you're going to have a lot of different options, or in this case, and then what we can do is we can just check the player direction to see if it matches a certain case, and if it does, do something based on that case. So the cases, we already know what they are, right? Because we have an enum. We can do player direction dot left. So if our player direction is player direction dot left, we're going to do something. And then we can copy this real quick and do the other one for right. And then we only have 3, so technically we should be able to do player direction left, right, and then default. But we'll leave that alone for right now. We'll just do the down as the none as well as an actual case, just so we know to check for that. It's very good to have default, because if you're none of these 3, it should do something else, which in theory, if it's not these 2, it would be none because it's not these 2. But that's okay. We're just going to write it here just so it's easier to read for us. But really, you should be able to just put it in the default and not have an actual case for player none. But we might have more stuff in our directions later. Who knows? So we'll just leave it like that for now. Cool. So now we have our case player direction left. And what do we want to do when our player is facing left? Well, what we want to do is we want to do a few things. First, we want to change its direction X to equal our minus, actually it's called minus equal, so minus equal our move speed. And what this is saying is taking our direct X, and we're going to subtract our direct X minus our move speed. And a quicker way to write that is just minus equals. So direct X minus equals. And we're getting an error on this because it's not, it's direct. Make sure you have the capital X. So direct X, direction X, is minus equal to our move speed. So every frame, this is going to update, and it's going to take in our move speed that we made, which at the moment is 100, and it's going to keep subtracting that from our direction X. So it goes further and further to the left. Well, now that we've done that, we can do the same thing, but we just need to do it positive, like I said earlier, on the right. So our direct X is plus equal our move speed. And now what we can do here is we don't need to do anything for a none yet. We'll come back to that. But now that we've actually set our direction X based on our player direction, we need to actually add this to our velocity. And to do this, it's very simple because that's what velocity is. It gives us an X and a Y. So we can come out of our switch statement, and right below here, we can just do velocity is equal to vector 2, and then we need to pass in an X and a Y. Well, our X is going to be our direct X, and our Y, because we're not affecting our Y when we do this, is just going to be 0. So our velocity is our vector 2, which is going to take in our directory X, direction X, right? Based on if we're going left, it's going to be negative our move speed. If we're going right, it's going to be positive our move speed. And then we just need to set our velocity to our position of our player. So we can call position, and then we need to add that to our position. So we can do position plus equals velocity. Now, if we do just the plus equal velocity, like I said earlier, we need to use delta time. So if we refresh, Nothing's going to happen because by default we're none and nothing's happening. But if we come up here, we now can control our player movement just by switching this right here, our player direction. So if we set our player direction to player direction.left and save, our player just zoomed. I don't know if you can see that, but our player just zoomed across the screen. And the reason why is because our game is not that powerful. So I'm probably getting tons of FPS. So it's going really, really fast. And that's why we need direct delta time on top of our velocity. So to do this, we can just do velocity times the delta time that we passed in. And then if we do this, our player is moving at 100 move speed no matter what. If we have 10 FPS, it's going to be the same speed. If we have 1000 FPS, it's going to be the same speed. And our player is now moving to the left. Well, we can come back up here to player direction.left, and if we save this, he'll actually go to the right. And then if we change it back to none, which means he's not going anywhere, he's back to idle, which is great. But if you see here, we don't have what we expect to have. Our player is idle in his idle animation, and he's going to the left, which is not what we want. So let's go ahead and make it so that we can actually use our animation when our player is moving. And we already have the ability to do that. We set that up in our last video, right? We're going to have a player state, and we have running. Right? So all we have to do is really call that. And we can do that by coming back down to where we set our player direction.left. Well, we want to increase our DirectX minus equal or move speed, but then we also want to set our current animation, which we get from the group animation that we talked about. And we can just set our current to player state dot running. Perfect. And then because he's running on the left and he's running on the right, we can go ahead and set both of these to running. And now he's running to the right when we play running. And then we don't want to forget, if he's not running, we want to make sure that we do player state dot idle, right? If he's not running, he needs to be idle. So if he's running to the right, he's running while he's running. And if he's idle, we'll do player direction none. Now he's idle. But we're going to have an issue right now because of left. If we go left, he is running, but he's running because he's facing right? He's facing right. And he's facing right because that's how our animation is. We don't have an animation for left. If we had an animation for left, we could use the animation for left, but we don't because we don't have to. What we can do is we can just check if he's facing right. And we can do this by creating a Boolean up at the top, right below our velocity. We can do bool, which means is it true or false, and we can call it is facing right. And it's a good practice to write is just because it's kind of like a question mark, right? It's a question. Boolean is a question, yes or no. And then I like to write my variables as question as well. Is facing right, right? Is it facing right? And by default, the answer is true. It is facing right. So that doesn't do anything if we save it and refresh. But now what we can do is we can check to see if he is facing right. Because if he is facing right, we need to make him face left. And if he is facing left, we need him to face right. And this is very easy to do right under our player direction. So before we set our animation, we can just do it at the top so we set the correct animation. We can do if is facing right. So is he facing right when we're going left? And if he is facing right when we're going left, well, we need to flip him. And we actually have a built-in feature that is called flip horizontally around center. And this does exactly what it sounds like. So perfect naming. It's going to flip our animation around the center of our character. And then we just want to make sure that now he's not facing right. So we want to make sure that we set that to false. Is he facing right? Well, no, we're going left. And if we save this, now when he goes left, he is facing left, which is fantastic. That's simple, right? However, we've now caused another issue. If he is facing right, he is going to be facing right now. But if we went left and then went right, he'd still be facing left. Or we'd have other issues because we never set him back. So all we have to do is the same thing that we did on the left. We just need to check if he's not facing right, right? If is facing right, well, we want to see is he facing left, which is not facing right. So we can use the exclamation point at the beginning, which just essentially means not. If not is facing right, right? If he is not facing right, then he is facing left. And if he's facing left, then we just want to flip him around again. Flip around, flip horizontally around center. And now we can again set is facing right back to true equals true. Perfect. So now our player will be able to run right. He'll be able to run left, and he'll also be able to be idle. And based on what he is doing, switch that up. Based on what he is doing, maybe I should rename that to idle. Maybe I do that a lot. If he's not moving at all, he's going to be idle, right? No move, no direction means he's idle, which is perfect. And then this will also work because right now he's facing right, but if he was going left and then facing left, you'll see it in a bit. He'll be facing left because that's where he was facing last time, and we never reset it. We don't reset his direction in player direction none. We just leave it whatever it was, which is perfect. And there we go. We now have player movement. It's updating every frame. However, changing player direction like this and then reloading the game is not how a game actually works. So what we need to do is we need to be able to add in, we're going to start with keyboard controls, and then we're going to move on to touch controls, keyboard controls for the computer, touch controls for mobile, which the touch controls are a little cooler, but definitely took me a lot longer to figure out when it didn't have to. So I'll tell you why later. But we need to be able to add in keyboard controls so that we can hold down A and D and move left and right, or hold down our arrows and move left and right. So let's go ahead and add that now. To add that, we need to add a special feature on our player class, just like how we have with HasGameRef Pixel Adventure. There's other components and stuff that we can add to then use in it. And for this one, we want to add a comma, and then we just need to say that we need keyboard handler. It already pops up as soon as you type in key. And this lets us know, hey, my component, my actual player itself, because there's two different versions, right? My component, my player, wants to be able to use keyboard controls and needs to recognize them. So we can save that. And then what we want to do is below our update method, just because I'm trying to keep all the main override methods together, we can actually now call, once we've saved that as a with, we can do onKeyEvent. And the onKey event is going to give us an event, but it's also going to give us a keys pressed. So we can track which keys are pressed, and that's what we're going to use for our game. You could use other stuff for events, but for us, it works perfect just to use the keys pressed. Now with the keys pressed, like I said earlier, we want to be able to get A and the left arrow for left, and we want to be able to get D or the right arrow for right. So to do this and save us a lot of writing code, we can go ahead and set it as a variable first. So we want to do final is left key pressed. And this is essentially going to allow us to check our keys pressed and see if any of our keys pressed contains the keys we're looking for, A and left arrow, and if that's true, then this is going to be true. So we can do that by writing keys pressed, not capital, keys pressed, which is right here, what we're grabbing, dot contains, and then we're going to check the actual key itself. And to do that, we write logical keyboard key dot, and then the key, and then whatever letter it is, in this case A, so key A. So this allows us to grab key A. However, we want to be able to grab key A or left arrow. So we can use the two pipes to write or, and then we can do the same thing. Keys pressed dot contains logical keyboard key, and then for the arrow, it's arrow left. Perfect. So now we're saying if the keys pressed contains either our logical keyboard key A or A key, or contains logical keyboard key dot arrow left, or left arrow, then if either of those are pressed down, is left key is pressed. And then we want to do the same thing for our right key. So to save ourselves some time, we can copy this and we can change it from is left to is right. And then instead of key A to key D, and instead of arrow left to arrow right. Perfect. So the exact same thing, but now we're getting the D key and the right arrow to actually be our right key. Cool. So now that we have is left key pressed or is right key pressed, we can check that with an if statement. So if left key pressed, and then this one we want to check and, right? If we're holding down A and D, we don't want to do anything, right? Because those counter themselves out. You might want to do that. It might make sense in your game if you want to, but then you're going to have to change the code a little bit. Otherwise, it'll always go whatever one you check first. So we're going to check if both of them are down, I don't want to do anything, right? So is right key pressed? So is left key pressed and is right key pressed? If they're both pressed, then what I want to do is I want to set my player direction to be equal to player direction dot none. They balance themselves out. If you're going left and right at the same time, you're confused and you're not going to go anywhere. Now that we know if they're not both pressed, we need to check to see if they are pressed. So we can do else if, and then here we're going to check if our left key is pressed. If our left key is pressed, then we just want to do player direction equals player direction dot left, right? Makes perfect sense to me. Hopefully it makes sense to you. Let me know in the comments if it doesn't. And then we just want to check is else if, and then we can do is right key pressed. And then the same as before, you probably already know exactly what to do. Player direction dot right. And then of course the last one, if no keys are pressed that are either left or right, we're not doing anything. So player direction is equal to player direction dot right. Now in the future, this is going to be different because we're going to have a jump button, but for now we don't. So we're going to set it as player direction equals right. Obviously, we'll talk about that later, but you should probably figure out how to do the jump key as well. Perfect. And if we reload our game, nothing's going to happen. And the reason why nothing's happening is because we're able to do key events in our component, but we're not actually telling our game to let that happen. So to do that, we need to head on over to our pixel_adventure.dart. And after where it says extends flame game, we need to tell our game that, hey, some of our components are asking to be able to use key events, and you need to let them do that. So to do that, we can just write with, like we have been. We can tell it that we want to be able to has keyboard handler components. And essentially this is what it kind of sounds like. We have the ability for our components to handle the keyboard. And if we save this and now refresh, we can hit A on a keyboard to go left, D on our keyboard to go right, A on our keyboard to go left, right arrow to go right, and left arrow to go left. But as you can see, we're still moving when I let go, which is not what we want. We want our player to stop moving if we're letting go of keys. And the reason for that is because I made a mistake, and instead of player direction equals right, instead of player direction being none, I put right. I was like, wait a minute, that shouldn't be happening. So there we go. That's why it's very important to, especially if you're copy pasting and stuff, that you always change it. But now we can hit A on our keyboard to go left, D on our keyboard to go right. We can hit left arrow on our keyboard to go left, right arrow to go right. We could also go right arrow and A to go left. They work together. And if we do A and D, they don't do anything. If we do left and right arrow, we don't do anything. And then if we do A and right arrow, and even D and left arrow. So it counters them out. So there we go. We now have keyboard controls. However, we also want to be able to set up touch controls because this technically is a mobile game that we're making. And yes, you'll be able to play it on your computer, but we also want to have you the ability to play it on a phone if you want to, because it works perfect for the phone. So we need to be able to add in touch controls. Now the touch controls are going to be a little bit different because we have to change some of our code around, and probably most of that is my fault because I didn't think about adding touch controls or how touch controls would work when I started making these tutorial series. So we're going to have to jump into our code and make some changes, but that's okay. It's not that complicated, but I apologize. So first things first is we need to switch out our player. So how we're doing our player right now is we're requiring this character. All right, so if we're going to be requiring our character, this is going to get very annoying because we're going to be passing it through different sections. So what we can do here is we can make this optional. That way we don't always have to require it every time we use our player. So we can get rid of the required, and then instead of where it says this character, we're going to get an error. What we need to do is just set it. So this says that we are going to, if we do not pass in a character at all, we're going to default to the Ninja Frog. But if I pass in a character at some point, then just use that character. That's what this means. So this way we don't have to require it. We'll set a default if we don't use it. And then if we ever set it, we'll just remember that and use that one. Perfect. Now we can go ahead and save that. Now, for some reason, when we import the raw keyboard.dart, this gets a blue squiggle. This is a flame issue, I think. We can actually just go ahead and import services instead. Just because I don't like anything being a squiggle, it makes me think that we've done something wrong. So let's go ahead and update that as well. We can do Flutter services, and then we can actually get rid of this, and everything should still work perfectly fine, but then no squiggle. So I don't know why it does that. That's not a me issue. All right, so now that we set up our player character, we can just add a little comma here to make it more readable. We still have the position, but now we're setting this character is equal to Ninja Frog if we don't set the character by default, which is great. Okay, cool. So now what we can do here is we can go into, we have to go backwards essentially. So our player is built into our level, and right here we're creating our player and adding it to our level. Well, we don't want to actually create our player when our player is found in the spawn points. We do want to set its position, but we don't want to create it. So what we can do here is we're actually going to need to add our player. We can do final player, and then we need to actually bring in our player. Now for our level, our player is going to be required. We're going to need a player in order to play a level because we're actually spawning him in. So we can make this required this dot player. So anytime we call a level, we are now going to have to pass in our player. But now we do have reference to a player. So instead of creating our player, what we want to do is we just want to do player dot position, and we want to set it to the same thing that we did before. But then this allows us to not actually create the player and pass in the position at the same time. It allows us to grab a player that's already created and then just manipulate the player dot position. And the player dot means that it's in the player's class. So we can actually get rid of this. And then we can still add the player in here because we want him in our level. That's perfect. But now we're grabbing in the player, and then we're just setting the player's position to be what we wanted, which is great. Now we can go ahead and save that. Now we are getting issues on our main pixel adventure, and it's because our level is now looking for a character, which we're not passing in, and it's required that we do. So we can do that by doing player, and then here we just need to get a reference to our player. So for the reference of the player, we'll do it right here. We'll do player, just like before, equals player. Great. And then we can pass in our player. Player equals our local player. Actually, we don't want to do it here because you can see right here, we can't reference our player until we've actually created our player. So what we need to do is switch this out of just outside of our onload, and we can go ahead and just put it right after we load the images, and that'll fix any issues then. Perfect. Now with our player, we're not actually giving it a default character, but now we can. So we can do character, and then the character is going to equal mass dude. Perfect. So we can hit save, and now we have a mass dude that is being created in our actual game as soon as we load the game, and then we're passing that into our level, and then we're using that in our level here. We're grabbing it, and then we're just setting its position. and then we're adding it to the screen so that it actually shows up on our level. Perfect. And then again, we're passing that in, the this dot character. We've passed it in, so it's no longer the ninja frog. It's our mask dude. And if we refresh it, it'll always be our mask dude until we change it. Perfect. So that's kind of how you can bring it back up to the outer parts of the game. That way we can actually have control of it, because we're going to add our joystick control on our main game file so that it's always at the bottom left of our screen and not the bottom left of our level, or even the bottom left of our player, which would be impossible to use, right? So that's why we had to change our code a little bit to bring it back out into the actual main game so that we can have access to our player, and then we can change our player's direction, for example, in our actual game file from our joystick. I hope that makes sense. Please let me know if it doesn't. Now, before we start writing our joystick, I want to show you an issue that we're going to run into if we don't fix it. Ask me how I know. Took me many hours to realize why it wasn't working properly. In our void main of our main.dart file, we actually want to change this into an async function, and we actually want to await our flame.device full screen and await flame.device set landscape. If we don't await it, it will work completely fine on our emulators and all of that stuff. But if you install your game onto a physical device, what will happen is the device will be portrait first, then set the joystick or any other HUD elements that we're going to use, and then switch it to landscape, because it takes a couple seconds for it to actually switch to landscape. By that time, we've already created our game and ran our game, because that's faster. So we want to actually wait. We want to load our game, set it to full screen, wait, then set it to landscape, wait till it's done, and then build our game. Again, took me hours to figure that out. So I wanted to make sure I brought that up here. Make sure you hit await, otherwise you'll have the joystick and it'll be perfect, and then you go and install it on your actual device and you're like, where'd my joystick go? So it gave me a headache, and I figured it out. It took a lot longer. I was like, wait a minute, super easy fix. But sometimes that's what happens in coding, right? I spent 4 hours trying to find something else out, and it was just, I didn't await for something to be done. So I wanted to make sure I brought that to your attention. Perfect. So now what we need to do is we need to create our joystick that we'll be putting on our game so we can control our player as well. So to do this, to keep our code clean, we like clean code, we're actually going to add our joystick right here, and we'll make a method ourselves, which will just be add joystick. Perfect. And then we can do control period to create a method, and then make sure we have the semicolon. So we're going to add our joystick to our screen, and we're going to put it all in this method so that it's super clean and easy to just separate stuff. Our onload's getting a little complicated, but it's not too bad. But it's better to, anything that has a lot of lines of code, we want to split that off somewhere else so we don't have to look at it. Cool. Plus, we can always minimize it then. So with our joystick, we need to actually create our joystick at the beginning. So we can do that right under our now player that we're calling in. We'll do late, and then it's going to be a joystick component called joystick. Perfect. And because we're using a joystick, we actually need to be able to drag stuff. And in order to drag stuff, just like we had to add has keyboard handler components, we need to add another one. So we can hit comma. And this one is going to be called drag callbacks. And essentially this just says, hey, I'm letting you be able to drag. And this will work perfect for our joystick. Good. So we can save that. Messes up the alignment a little bit. We got a lot of stuff on there. So now with our add joystick, what we want to do is we want to set our variable joystick to a joystick component. Great. Now with our joystick component, there's two things with a joystick. There's the actual joystick background, which is what, of course, it's going to look like a background. And then there's also the joystick knob. Now we need to create these, but we don't actually have these in our assets images. There is no joystick because we just weren't given those images. So we're going to actually have to create it ourselves. Now don't worry, it's very easy. We're going to be using a free software that works on your browser called Figma, and we're going to just create our joystick ourselves. And this way you can make it exactly how I am or make it however you want. I've also created a GitHub for my project. Every time I update the project, I update the GitHub. So if you do want to, you could download the project, and the images that we're creating now will be in there. But we can just switch to Figma. So inside Figma, figma.com, create an account if you don't have one. Hopefully you already do, because it's awesome. We just want to come up here, create a new project, and then come up here to our shape tools, and we can do an eclipse, and we can just click. And then this eclipse by default is going to be 100. We actually want, you can click this button right here to make them the same. And then we just want this to be 64 by 64, width and height of 64. And then for the fill, we're just going to make it completely black. And then for the transparency, we're going to do 50%. So it's essentially a black circle with 50%. And then we can Control R to rename it. And then rename it to joystick, capital J. Great. And then we can go ahead and click the eclipse tool again, and we can click. And then in this one, we're actually going to make this 32 by 32. And then for the color, we can just make it a nice little grayish white. And then we're also going to make this 50% transparency. Great. And if we cover them, this is what our joystick is going to look like. Nothing too fancy. I am definitely not an artist. You can make this as complicated as you want, make it look as fancy as you want, whatever you want to do. But essentially just make sure you have a joystick icon, which we'll use for the background. And then this one, we're going to Control R. We're going to rename this to knob because it'll be our knob. Perfect. And then we can select both of these and then go to export, and then it'll say export to layers because we have them both selected, and then we can just export them. Now here we have, we're in our downloads that we've downloaded. It's an untitled, because we didn't name it, it's an untitled zip file. We can just open these up. And then what we want to do is we want to go into our project, right click, and then do reveal in File Explorer. And inside of our assets, inside of our images, we just want to make a new folder in here. You can call it whatever makes sense for you, but I'm just going to do HUD, all capitals, because these are going to be our HUD elements, which means they're overlaying the screen. And then we're going to select our joystick and our knob, and we're just going to drag those in. Perfect. We can close out of all of this. And because we've added new images to our file, we want to go into our PubSpec YAML, come down to our assets, and then right under, it doesn't really matter where we put them, but we'll do assets, dash assets slash images slash HUD. And then make sure you have the last slash at the end. And then we'll save this, which tells the Flutter, hey, I've added more images. I need you to use them. Perfect. So now that we have our images, we can go ahead and create our actual joystick. So first we will go ahead and create the knob. And then the knob is going to take a sprite component because that's where we made an image. We're going to use that for our sprite. And then inside our sprite component, we need to just give it a sprite. And the sprite that we're going to do is we're actually going to call sprite. And then we need to grab in an image. Now we already have images right here. We're already loading all of our images that we've ever used in our game. So we can do images dot from cache. Hopefully you remembered that. And then we just need to pass in our directory. So it's HUD, and then it's our image, which is knob, capital K, .png. Perfect. And then we can add a comma here and a comma here to make that look nicer to read. Great. Now we do want to be able to give our, we also need to give our joystick a background. So right below our knob, we can do background. You have to give it both. You could make the background transparent if you don't want an actual background, but if you don't add a background, it will throw an error. So make sure you add both a knob and a background. So for a background, we'll do sprite component again. We are actually going to pass in a sprite. Again, it's the exact same thing. And then that will be a sprite. And then the sprite images is going to be images dot from cache. And then this one is HUD slash joystick for the background, PNG. And then we'll add the commas so that it's easier to read. Perfect. And then if we refresh, well, we're going to get an error. And we're going to get an error because, well, we're not adding a margin. we have to either add a margin or a position. And the cool thing about the joystick is we can add margin, and the margin is going to be where we want to actually place it. So we want it at the bottom left. So we can actually call, make sure I'm in my joystick. We can actually call margin, and then the margin is going to be const edge insets dot only. Let's make sure we import it. Dot only, and then we want to put it on the bottom left. So we'll do left 32, and then we'll do bottom 32. And you can make these whatever size you want. That's up to you, whatever you feel makes sense for your game. But we need to make sure that we add a margin or a position, otherwise you'll get an error. I just want to make sure that you knew that in case you get that error. What happened? Well, you don't have a margin. Okay. Cool. Now we can't see our joystick because why? Well, we've created our joystick, right? But we're not adding our joystick to the game. Even though this is called add joystick, we need to add it to our game. So we can do that very easily just by doing add and then add joystick. And now if we save and refresh, there's our joystick. Now our joystick doesn't do anything, but you can see it just like this. Now, we don't necessarily have to add a radius. I think this radius works perfect, but you can change the radius if it doesn't work perfect on your image. And you can do that just by doing under knob, under knob here, you do knob radius. And then it's just a double. You can make it really big if you wanted to. And now, as you can see, it drags out further than my circle. So just keep that in mind. But how I've designed it, or how I've showed you, this looks fine. It goes halfway through the circle. I'm okay with that. Cool. Now we've created a joystick, which is perfect, but our joystick doesn't do anything. It's just a joystick. So what we need to do is we need to check where we're at on our joystick and actually set that to our player's direction, which is very easy to do as well. To do this, we want to come outside of our onLoad event, and we're going to call our update event in our game itself. And to keep our code nice and clean, we're going to create another variable, another method, and we'll call this method update joystick. And we don't necessarily have to use the DT here because we're going to be using it to call our player's movement, which has DT in it already. So we don't need it here, but depending on what you're doing, you might. So just pass that in if need be. And then we'll hit control period to create a method called update joystick. So in our update joystick, what we want to do is we want to be able to grab our joystick's direction, and then based on our joystick's direction, we want to use that to set our player direction. So we can do this by making a switch statement. Switch statement. And then what we can do here is we need to pass in our joystick, which is our reference to it, dot direction. And now, just like we did our player direction, we now have the ability to check our joystick direction. So in this case, pun intended, joystick direction dot left. So we want to check to see if our joystick direction is left. If it is left, then we want to do something. And we'll copy this, and we'll do the same for right. And then if it's not left or right, it means we're not really doing anything. So we can change our default and just add a break here. And then we'll set something in here. We'll set something in here to do our idle. Now we do technically have a reference to our player. So really what we can do is in our joystick left, we can just do player dot player direction equals player direction dot left. And if we save this and we use our joystick and we go left, our player is now going left. But he's not stopping, and we'll get there. And then we can do the same thing right here for player direction dot right. And now we have the ability to go left and the ability to go right, left and right, left and right, left and right. However, it doesn't stop. So to make it stop, that's where the default comes in. So we can do the same thing, but if there's no movement, left or right, then we can do none. Perfect. So now left, let go, we stop. Right, let go, we stop. Now, the only issue is this is a joystick. So joystick can go up, down, left, and right. And as you can see, if we go around the circle, we're going to stop a lot. And that's okay, I guess, if that's what you want, but this looks like it can go all over the place. Plus, to make it smoother for the user, what if they're right here? I would still consider that left, right? Right here is still left, but it doesn't recognize that. So to make that easier, we can just add more cases. If our case is joystick direction left, but we also have option to up left, and then we also have option to down left. And now, if we're on the left side at all, up, left, or down, we're able to move left. And then we just need to do the same for the right. So case, joystick direction right, we can do up right, and then we can do down right. And essentially what this is saying is we're going to switch on our joystick direction. If our joystick direction is left, up left, or down left, we're going to set our player direction to player direction.left. If our joystick direction is right, up right, or down right, we're going to set our player direction to player direction.right. And if it's anything else, which is not possible other than idle, because we're setting all of the other sides, well, then our player direction is going to be equal to player direction.none, because they're not going left, right, up, left, down, right, all of that stuff. Perfect. And now the last thing, we might not always want controls here, so we can come back here real quick, just make a Boolean that says show joystick, and then by default, we will set it to false. And then what we want to do is we want to check to see if our show joystick is true. If our show joystick is true, then we want to show our joystick. If our that's really hard to say, show joystick is false, then we don't want to do that because we don't really need this on a desktop computer. We have keyboard controls. What we can do here is we need to be able to hide this. So right here where we call add joystick, what we want is we want to do if show joystick, meaning if it's true, then we can add our joystick. And we need to do the same for our update, because if we update and our joystick is hidden or we never added it to the game, it's going to throw an error. So we can do the same thing, show joystick. And then if we show our joystick, update joystick will actually work. And then if we refresh, now that we have it as false, it doesn't work. And now we can use our A and D, our left and right. However, if we're on a mobile device, we can do true. And then if we refresh, we can no longer A and D, like it doesn't work because we now have a joystick. So obviously we wouldn't want both because you can't do both, A and D or left or right, right? Those don't work. So we do need to be able to add or hide our joystick. And we can just do this right here. What I would say is if you're making a desktop application, just make it false and then build the application. If you're making a mobile application, set it to true and then do it that way. We could also add it into the settings later. Maybe someone on the computer does want to do it this way. Not sure why, but maybe they want to. So you could set it up like that as well. So that's kind of how that works, which is good. But yeah, there we have it. We've now added in player controls. Our player can go left and right. And then we also have the ability to use keyboard controls. So our player can use left or right with the keyboard, which is what we'll be doing in testing for the most part. But yeah, you can download this game and install it to your device and actually use it with a joystick. So I hope you enjoyed this video. Please subscribe. In our next video, we're going to be adding gravity as well as collisions and even probably player jumping. So check out the video on the screen right now, and I'll see you there.